All right, so now let's move on to question 3. So we have question 3A and 3B. Both of these require involve exponential equations. So again, an exponential equation is an equation that has a base with some exponent, and your variable is the exponent, and then is equal to something. So these are exponential equations. Okay. Now, there's two main ways to solve exponential equations. Either you're trying to establish an equivalence relation, as we're going to see in 3A, or you have no way of establishing an equivalence relation. So then you have to introduce log or natural log into your problem, which we'll see in 3B. So what is the equivalence relation? The equivalence relation says that if you have an exponent and a base is some exponent, and on the other side equal sign, you have the same base, but a different exponent, then you can basically say that the two exponents are equal to one another. Okay. So this is a problem. 3A is a problem that this would be a possible, because notice on the left-hand side here, we have a base of 4. Now, whereas on this side, the right-hand side, we have a 64. Now, what this tells us is we have to think about, is it possible to make 64 base 4? And the answer is yes, because 64 is equal to 4 cubed. If you're unsure of whether or not you have the same base, or is it possible to bring the same base, well, just look at your equation, see what base is you have, what's the smallest base you have, and then keep dividing the other number by that and see how many times it can evenly divide that number. If it can be evenly divided, for example, here 64 can be evenly divided by 4 3 times, therefore 64 can be written in base 4. If that's not possible, then you most likely have a scenario as you would see in 3B. Okay, so now we established this is possible to get a equivalency relation. So now let's take our equation and write this as 1 over 4 cubed equal to 4 2x plus 1. Now remember, when you have exponents in the denominator, if you move them to the numerator, they change signs. So we have positive 3 in the denominator. So when it comes to the numerator, we end up with 4 to the negative 3. All right, so here we clearly have the equivalence relation. We can set the exponents equal to one another and then solve for x algebraically. We can subtract 1 and then divide by 2. And this would give us x equal to negative 2. Now, it's always good to take your result and then plug it back in to make sure it works. So let's just quickly do that over here. So if I plug in 2, negative 2 plus 1, well, that gives me 4, negative 4 plus 1, which is 4, negative 3. That's 1 over 64. Okay, so that works. Okay. Now let's look at the next problem. 3B. Now what happens is this is the part that's the exponential. So we would first want this to be isolated on one side. So we would go ahead and subtract 6 on both sides, and we end up with e to the negative 4x equals 9 minus 6, which is 3. So I subtracted a 6 and I get this. Here I have base e, here I have a 3. There's no way I can go from base 3 to base e. It's just not possible. So in a problem like this, what we have to do is introduce log on both sides. Okay. Now, generally, you could just do log on both sides, or you could do natural log on both sides. Since it's e, it just makes sense to use natural log on both sides. But again, this would give you the same answer regardless of which one you use. But if you see E, preferably use natural log. Okay, so now that we have this, well, using the properties of log, this is an exponent. It can be moved forward to give you -4x. Natural log of E equals natural log of 3. And then this is why if you're going to introduce a log function, it's better to introduce natural log because natural log of E is equal to 1. So this is equal to 1. So we're just left with -4x equal to natural log of 3. And then finally, we could divide both sides by -4. So this gives us natural log of 3 equals -4. That would be your final answer. It's better to keep it in exact form, so you could just stop here. You don't need to convert it to a decimal unless the question specifies to give a few decimal places. Aside from that, you just keep your final answer in this way.